let's start with the demonstration. Let me please introduce in few words what are we going to see, and then we'll step into the software and the couple of softwares, because we are talking about an integrated system between a DSS software and a DentalCad software, so that we will be able to see how does it work in a real clinical case. Okay? Perfect. So, as I said, we are talking about two different systems that are in cooperation to each other. Okay? So, the first software we are going to see is basically a photo editing software. You certainly know Photoshop. DSS software is a kind of a simplified Photoshop, because inside this simplified version of Photoshop, you have only what you need and everything you need regarding dentistry. Okay, nothing else. That means that it's going to be much simpler, much user-friendly, much more user-friendly, and much quicker. Okay, at the end of the process of this photo editing software, we will import this project inside our CAD, and we will see what is going to happen. Okay, great. So in order to start a project, as you can see, there is a form that has to be filled in name, surname, and then with a small tick on privacy that will activate the export function. That is the one that is necessary to export the project inside the CAD. And then we can save it. Once we open our software, we have to insert a series of pictures. Well, as you can see in this page, we have several boxes. Some of them has been filled with pictures, some of other has not been filled with any type of picture. And most of all, as you can see, there are two boxes with a blue framework. It means that only two boxes has to be filled in a mandatory way, which are the face frontal and the intraoral frontal. Now, let's talk about some rules that need to be respected in order to obtain a good project. As you can see, the full face of the patient has to be done. The full face has to be taken, okay? Not only the mouth, but the complete face. And the position of the head of the patient is very, very important. The patient has to look straight into the camera, and there must not be a rotation or inclination of the head. In this way, we will have a reliable situation. Okay? And then the other extremely important point is the one of the picture of intraoral retractors. It is not important to take, in this case, the full face or the detail. You can choose whatever you prefer. But the most important thing is that the position of the head of the patient in this picture has to be as close as possible to the previous one. Okay? So you have to take two different shots. The first one with retractors, the other one without, and position of the head of the patient must remain the same as much as possible. Okay? And we are going to see the reason why in few steps. So, the first step that we need to fulfill is the one of the calibration. In this step, we are going to do three different actions. The first one is to find the correct position of the picture so that the bipupillar line from here to here is straight and parallel to the floor. The second step is to insert this red line exactly where we imagine the future interincisal line of the teeth of the patient. So I assume that the line between the front incisors will be exactly here. And then calibration, which is the most important step. By clicking on length scale, we are going to give a parameter to the software. In few and simple words, the software needs to know which portion of this picture corresponds to a given measurement. This given measurement is 170 millimeter, 170. So if I draw a line from here to here, I tell the software this portion of the picture corresponds to 170 millimeters in reality. It is a simple calibration, okay? Thanks to this action, from now on, I will be able to obtain completely reliable measurements, as you will see in the next step. In this step, when I click on linear measurement, I am able to click from here to here, just to make an example, and see that these measurements do correspond to 170. Okay, we don't care at all about this measure, but if we need to consider, for example, this data or this data, we know that it is perfectly real, okay? So, in this step, we are kind of in an analysis step. We can analyze the picture and the original situation of the patient in all its details. We have taken measurements, but for example, if we want, we can take straight lines or curved lines in order to evaluate some details. For example, I show you how to work with these lines. We want, for example, to understand which is the axis of one tooth here and the other one here, okay? So that the dental technician is able to understand, okay, there is a slight difference between the axis of the teeth of the 13 and the axis of the 23. This is an important element. This is something that maybe can be correct, okay? Now, I stop for a moment just to let you perfectly understand which is the potentiality of this instrument. This is an instrument that most of the time is driven by dentists for the first time. So dentists take the picture and dentists do the analysis. The dentist realizes that there is this situation of a difference and can communicate to the dental technician which is the original situation and what we want to achieve. So dentists can say, we have to correct the axis of the teeth in this way so that they will be perfectly parallel. Got it? Okay. And then probably the most important step is the one of the incisal edge. And I want to draw it from the beginning just to show you which is the potentiality of this instrument. Well, we just have to turn on this red line and we have to click along this one and draw a perfectly symmetrical line. Okay? In this way, we are able to draw the ideal line of the smile of the patient. Obviously, it is up to the dentist to decide which is the ideal line of the smile. But in this way, we can see that it can be perfectly parallel to the ideal horizontal plane. Okay? 0 degree, exactly as the ideal horizontal. And then there are so many other tools. I do not want to waste your time by showing all of them. We can set up detailed training on them if you want, no problem at all. Just move to the next step in order to see the situation in the bigger picture. Now, as you certainly remember, we have inserted two different pictures. The first one, which is the one that you see here, and the other one with retractors. Now, what we're going to see basically is to make an extraction in this picture in order to create kind of a hole and superimpose behind this picture the other one. Okay? So the action that we are going to do now is to cut, like with the scissors, we have to cut the inner border of the lips. In this way. Okay? It is very, very simple, much simpler than Photoshop. finish. Okay? In this way, we are able to perfectly superimpose the two pictures, as you can see here. Look at the laterals. Okay? We move from one picture to the other, and laterals are perfectly superimposed. And also another great benefit we have is the fact that we can see the design of the border of the lip on an intraoral picture, which is something that dentists and technicians never have in their common situation. It is a detail they are not able to rely on. Correct? Okay, great. And now we just have to choose the template of the teeth we want to use. As you can see, DSS gives you the possibility to use standard shapes or 3D shapes. In this case, we need to choose one of these 3D shapes to obtain an automatic conversion from 2D to 3D. So once we have chosen the one that is the most ideal for us, we can move on to the next step, and we can decide which are the teeth that we want to edit. Now, you can see only 4 teeth, 4 upper incisors, correct? 1, 2, 3, 4. But it is up to me, it is up to the user to choose as many teeth as requested. For example, if I want to make visible a molar of the lower arch, I can do that without any problem, as well as in the upper arch. Okay? It is up to me. Okay. Now, for this specific kind of restoration, we need only the 4 upper incisors. Now, what I can do, first of all, is to delete the texture and turn on only the outlines, so that I will be able to rely on the posterior situation, on the original situation of the patient, and to edit a new design by following the original situation. For example, let's take this lateral. I can see that in the original situation, the lateral has this shape, but I want to modify it and to extend a little bit the height of it. Or, I don't know, the inclination, for example, or the shape. It is very, very simple. Okay? And I can do that for every type of tooth. Okay? But the most important thing is that we are able to obtain real measurements on this new tooth. So, for example, if I want to take a measure of this new central incisor, I am able to take it 10 millimeters. And regarding the other measure, it is 8. So, from the point of view of the golden rule, we have obtained kind of a perfect situation. The proportion should be 1 to 0.8. Okay? So in this way, we know that we have obtained a perfectly tooth from the aesthetic point of view. Then, of course, we are always able to modify it, to change, to correct, whatever we want to do. Okay? So, once we have decided what do we have to do, we can focus on shade. We can make it whiter or more gray or more yellow if it is requested, according to the personal taste. And then we can see the final situation here. Okay? Great. So we have finished with the first step of the 2D, 3D workflow. We have obtained a reliable preview of the final situation of the treatment at the first appointment. Okay? And we can share with this result with patients. We can share this result with dental technicians, not only with this before and after preview, but also with a very, very reliable and precise PDF report that we can automatically edit by clicking on this icon. In the report that we can edit, we find all the measure, all the references that we have taken along the clinical case. And as you can see, once we design the teeth, here we have all the detailed measure about the teeth that we have edited. 1, 2, 1, 1, 2, 1, 2, 2, and so on. Okay, so this is a very, very reliable scheme that we can share together with patient, but most of all with dental technician. Okay, no, it's not this one. Okay, it was this one. Great. Anyway, once the patient has approved the final result of the treatment, we can go back to the home page and export this project. Export tool is something that creates a kind of a zip folder that can be opened only by another DSS as well as a DentalCad software, which is the really important thing that we want to show you now. As you can see, .dss file means this kind of encrypted file. So dentists send this kind of project to the dental technician. Dental technician received it via email, via USB key, via Dropbox, whatever you prefer, download it and open the DentalCad software. We are going to use a specific function of the DentalCad software, which is the one that you can activate by clicking on DSS icon here at the bottom. The first thing I would like to show you, I would like to let you notice, is that once we import the DSS project here, we can see the order manager that has been automatically filled from the beginning to the end. Okay, so you do not have to define anything here because the software automatically recognizes the teeth that we have edited in the 2D, the type of the library that we have chosen, the anagraphic data, as well as the data of the CAM that we want to set. Okay, what we can modify is the possibility to import the antagonist or not, or to modify the parameters of the CAM. But for other topics, it is perfectly set. I open the folder, the project, the restoration, sorry. And let's start from the very, very beginning of it. Okay, so in this situation, we have three different elements that are superimposed to each other. The first element is obviously the picture that you can see here. The second element is the S.R.L file that we have previously scanned or imported from another scanner. It can be also an intraoral impression. Okay, it can be everything. Okay, and the third and most important element is the design of the teeth that we have done before. Okay, can you see the red outlines? Okay, the red outlines is exactly what we have done here. But if in DSS project it was simply a 2D photographic editing, in the DentalCad software, we are able to transform this 2D in a 3D library. Okay? And when I speak about 3D, I am talking about a three-dimensional tooth. As you can see here. Okay? Now, there is something that maybe you have already noticed. We haven't designed any type of margin line, correct? There's no margin line to be defined here. And this is a very, very useful tool because margin line, as you perfectly know, is a limit, is an edge that we are not able to overcome. In this specific module of the DentalCad, we are able to draw, to define, to correct, to sculpt the shape of the teeth without any limitation. And let me please show the advantage of this situation. Let's focus on these 12 tooth. Okay? From the transparency, you can see that we have designed the cervical edge on a level which is much higher than the original one. If you have to design a margin line, most of the time you have to design it along the original cervical edge because it is much precise, much reliable, more reliable for the cut. In this way, we can extend it. And which are the benefits that we can obtain from this free design? For example, we can print this kind of prototype, this kind of mock-up, and use it as a guide for the laser surgery. Let's assume that our aim is to increase the height of the gingival edge. We print this mock-up, and with the laser, we do in this way, okay? So we will have removed all this gum, this part of the gum. Okay. And then there is something more that we can do. For example, we can print this kind of mock-up to help the soft tissue to recover after the extraction, because we will press it and we will push the material, the composite, inside the mock-up on the soft tissue to help it to recover in a much faster way and in a much safer way for the soft tissue. Okay, and this is one advantage. And then I would like to focus also on another kind of advantage that you can obtain by seeing this kind of opacity, this kind of a transparency. Let's assume that you, as dental technician, send to a dentist a screenshot of this situation. Okay? In this way, dentist will be able to see how much portion of the tooth has to be prepared and how much portion has to be saved. So, there are so many different advantages that you can obtain by using this kind of protocol. But we are only at the very beginning of it. Okay? Because once we have defined everything, we can move on. We can have a simple check of the connectors. Okay, in this step of DSS, you do not have to correct connectors. Or, in a better way, you do not have to see any type of connectors. Because if you see a connectors, it means that you are not able to print, you will not be able to print one single mockup, one unit mockup. Okay? So, if you do not see any type of connectors, it means that you have done a good job. And once you have checked your good job, you can go on. You are in the refinement part. And let me please show you what happened here. I turn off the jaw. Okay. Can you see it? So, what we have here is empty crowns for the laterals because we had the crowns here. Okay. We have reduced them and we have obtained empty laterals. But considering that, given that we didn't have any tooth for the central incisor, we didn't have any type of reduction for the central incisor. So, in one single project, we have been able to print, or mill, as you prefer, lateral as provisional before the milling, before the preparation, sorry, and full crowns for central incisors. And you know, guess what? The most important step is that if we turn on the red outlines, we realize that they are almost perfect, exactly as we have showed to the patient. So, this STL file is an open STL file that can be sent directly to the milling machine or to the 3D printer so that it can be tried immediately inside the mouth of the patient. But that's not the end of the story, okay? Because there is something that we haven't spoken about so far, which is the minimum thickness. We haven't considered anything about the minimum thickness so far. So it might happen that we have designed something that is too thin to be milled or printed, okay? But we have a solution for this kind of problem. By the action of create complete model, we are able to create a complete solution, a unique solution given by the original teeth of the patient plus the prototype plus the mockup, as you're going to see in few steps. I mean, we are going to print, maybe it's better to print than to mill, but maybe it's fine as well. We are able to create this unique piece that we will be able to use to create a silicone impression. The impression can be fit inside the mouth of the patient so that with acrylic or composite, we will be able to create the mock-up, the prototype, directly inside the mouth of the patient. So what I meant was that now we are able to print or mill this entire arch or a portion of the arch. We can extract also from canine to canine, for example, use it to create an impression so that we fit the impression inside the mouth of the patient, and with the acrylic of composite that we can inject, the mock-up can be printed directly, can be edited directly inside the mouth of the patient. But something that I would like to specify is that once we go to the export, we will obtain all the files, all type of files that we have edited so far. So we will see only the direct mockup or the complete model, and the complete model, sorry. Okay? It is quite a huge file, so it takes quite a long. But once you are in the export, you just have to choose the directory where you want to save your files, and you will see that your files are two different files if you have edited both the complete model and the mockup, or it will be only one file if you have created only the mockup or only the complete model. Okay, export. We save it in, I don't know, for example, create year. Okay. So the first one, the one with the lower huge, is obviously this one. Okay. And the other one is this, which is much heavier, of course.